Appreciate you coming today. I guess you have a translator so you can understand what I'm saying. We're going to be talking about free energy or open sourcing. Okay. Okay. Next. All right. When we talk about free energy, we open up with this statement. Imagine a world in which every home has its own power device that enables you to basically gather energy in such a way that no fuel has to be added. No fuel from gasoline or from the grid. Imagine every vehicle being able to drive in such a way that you never have to stop for fuel. Imagine every appliance having its own power source that you never have to plug it in. That is the world of the future, and that's what we track in our free energy news. Okay. We're going to be talking about what is free energy, and then we'll talk about the top 5 free energy technologies closest to market and their open source counterparts. And then we'll talk about a new open source project called the Waters Effect. Usually when people think of free energy, they think of, that's impossible. But actually, we know through history that there have been many things that have also been impossible that have come to market. We're not talking about perpetual motion. The energy comes from somewhere. It comes from the wheelwork of nature. Okay. Now, when we talk about free energy, there's something called cognitive dissonance, where the truth about something is so hard to believe that you want to go with another paradigm. That Building 7 on September 11th could not have fallen at free fall speed without help. They had to remove the construction barriers through a planned demolition to bring that building down in free fall speed. People don't want to believe that because that means there's corruption in the government. And so they ignore the facts and go with the mainstream tail, so to speak. And so the whole purpose of this September 11th event was to instill fear in people. That was the agenda behind that, to have massive public, basically mind control. The antidote to fear is love. This is a person that you'll be seeing later in our presentation who's part of an open source project. Okay? Free energy is all about freedom. If you have a device that doesn't have to be plugged in, or your car doesn't have to stop for fuel, or your house, you can grow as much food as you want, you don't have to worry about the electricity bill for the power company, that's freedom. And it empowers the individual because now they can, rather than having to worry about paying all these bills, they can start doing what they love and not have to be empowered, not to be subject to the corrupt powers that be. Okay? So free energy really is a revolution. And I would like to invite you to be part of that revolution. It empowers the individual. It is power to the people. And also, we talk about many ways that the economic situation could collapse. And free energy can actually create jobs. It can also provide cheap energy, and it can provide hope for a better world. And hope is a really powerful thing itself. Also, it can enable more people to survive. If things do fall apart, if you have the free energy devices, then you can live comfortably and survive and build a new society on the back end. Okay. When we talk about these revolutionary ideas, truth generally goes through three phases. First, it's ridiculed. We know that. Second, it's violently opposed. And third, it's accepted as self-evident. Everyone knows that. When you're one step ahead, you're a genius. When you're two steps ahead, you're a crackpot. And so the people who hang out with us in the free energy world are the crackpots, and you people can relate to that. Being out there on the leading edge of society, you're considered crackpot sometimes because it's just too far ahead of where everyone is. Okay. When you're one step behind, you're the government. Free energy, there's conventional and unconventional. Solar is free energy. Wind is free energy. Geothermal, tide. That's on the conventional. That's not going to break any laws of physics. And then there's the exotic. Cold fusion, magnet motors, electromagnetic over unity, water as power, water as fuel. And that's just a start. Here's a longer list. You can see that it goes on and on. Go ahead. There are actually 25 genres of each of those categories. There's 25 conventionals and 25 unconventional free energy genres. And each one of those have many teams helping bring them forward. What is the ideal energy source? We talk about it's affordable. You can buy one. It's environmentally friendly, has continuous output, load following, meaning that if you need a lot of power, it gives you immediately what you need. It's robust and low maintenance, scalable. You can make big, you can make it small, portable. Materials are sustainable, practical, and there's a good team behind it. And these are kind of the criteria we use in determining what are the best technologies as we try and bring to your attention the ones that are most promising. In 2005, I founded the New Energy Congress to help find the best technologies and to rank them. Okay. And in the last 4 or 5 years, I've shifted my emphasis from the top 100 to the top 5, because that's a much more digestible size. And we're focusing on the exotics. You know, there's plenty of people talking about solar, wind, geothermal, but there's hardly anyone talking about cold fusion, magnet motors, these things that are supposed to be impossible, but there are working prototypes. New Energy Systems Trust, I founded this 2 years ago, May 1st. And its purpose is to provide an incubation service to bring these technologies to market, to provide the professional services, and to help to coach the inventors. Here's the steps you need to go through, find investors, etc. Okay? So now, let's slow down and talk about just a few of the top 5, or the top 5, and some open source variations of the top 5. Some of them have close variations, some of them are a little more distant, but let's take a look. When we talk about open source, here are the criteria that I believe are the most important attributes of an ideal open source project. First of all, it needs to work and be validated, that people who know what they're talking about have seen it and confirm, yes, this is real. Second of all, it needs to be easy to replicate. Third, it needs to be inexpensive so you can afford to get one. Also, fifth, it needs to be unencumbered in its intellectual property. You can't have people who are going to be claiming, hey, that's mine. You can't, what are you doing with that? And then it needs to have significant power output. You need to be able to get a lot of power out of it, so it's worth your while to make this thing. If it has those criteria, then you've got something really good. And we've been, in the last 10 years, I would say we've had 50 different open source projects, but none of them have really had all of those attributes in them. So we're still looking, but I think today we're going to be telling you about one that may fit every one of these. And so you're going to be the first to hear about this project, okay? Go ahead. What is number one in our top 5? Now, solar hydrogen trends. You say, well, that sounds conventional. Solar is conventional. Not these guys. This one actually doesn't have anything to do with solar as in the sun needing to be overhead. This is a company in Los Angeles, and I'm hoping to visit them on my way back. My flight goes through Los Angeles, and hoping to spend some time. They're going to be visited by a government entity to do another test. They've had 2 third-party tests, and they have 16 different things going on at the same time. They have cavitation, cold fusion, electrolysis, 16 different phenomena happening at the same time, so that you can take water and turn it into hydrogen, so 1 liter of water turns into 1 kilogram of hydrogen gas. Normally, it takes 9 liters of water through electrolysis to make 1 kilogram of hydrogen gas. And let's go ahead and go to the next slide. They have been third-party tested. This is one of the cover page of one of the reports. And go ahead and see the next page. This is a third-party group that this is what they do. They test gases. They test both qualitative and quantitative analysis. This is what they do professionally all day long, all the time. This is not somebody who's not used, doesn't have the equipment. This is a legitimate company. Go ahead. The report. Look at that. We'll look at the numbers on the next slide, but notice on the last column, which is the average of 3 different tests that they did, that you've got water, and the output is 93.1% hydrogen. Last time I checked, water is composed of H2O. For every 2 hydrogens, you have 1 oxygen, and they're ending up with 93.1% hydrogen because the oxygen is going to hydrogen. The oxygen has 6 protons each, which are turning into hydrogen through basically a fission process. So this is a nuclear technology, and it's super cheap. The device is the size of 3 microwave ovens turned on their side. It's very small. And go ahead, next slide. I did the math on the second to last column. This is my math. Just taking the input watts, almost 700 watts to power the thing, and it produces 2,000, 322 liters per minute. I mean, if you had a hose this big, it'd be going, it'd be loud, with 700 watts. Okay? Equivalent to 402 kilowatts output. That's 577 times more energy out than what it took to make that gas in the first place. That's pretty cool. Only problem is that it's getting rid of oxygen. And I like oxygen. It makes it easy to breathe. It's kind of nice to have on the planet. So if these guys get really popular, we're going to have someone else figure out how to replace the oxygen, right? Okay. What about an open source alternative to these guys? There's a guy named Peter Crunk in Florida, HHOgastechnology.com, who is experimenting doing similar kinds of things, not really close to these guys, but he is making a lot of gas using water, and he's not the only one. There are about 1,000 other people and companies around the world who are using what's called Brown's gas and electrolysis and cold fusion, but there's really no open source project that comes close to what these guys are doing. What about number 2? This one is actually a classification of technologies. Last year when I gave a presentation here, there were, I think, 14 that we had found by then. Now we've found 51 different people from around the world who have put videos on YouTube that we found out about, who are making a smaller motor power a larger generator that is able to loop back, keep the small motor turning with excess energy left over. We call it Q-mogen. The letter Q has like self-loop, and then the tail of the Q is the energy left over. So we named it Q-mogen for motor generator. So qmogen.com takes you to our page where we feature these 51 so far. Actually, somebody should send me another email today, so there's 52 now, of these self-loop motor generator systems. 16 different countries, as far as I can tell, all independent from one another. Each one of them thought they came up with themselves. They invented it. Probably what's going on is that as you have the smaller motor powering the larger generator, you get a resonance going on with the environment, and you have excess energy showing up in the system. Some kind of, harnessing the ambient air. I'm not sure what, not air, but like electromagnetics things. But it works. Okay, next one. Are there any people open sourcing this? Actually, there are about 7 different groups that are in various phases of sharing the technology. One guy, go ahead, next slide. Well, these guys, a quantum energy generator, QEG, is kind of a remote Q-mogen. It's not really the full-fledged Q-mogen technology, but they are open sourcing, and they claimed 10 kilowatts, enough to power a house. They're deep in research and development. And they are, they have a long ways to go to have something where you could download the plans and power your house with it. They haven't even validated that their plans will produce more energy out than what they put in yet. But they do have, they're very open about sharing what they have, and there are several groups who are trying to replicate it. So we'll see where that one goes. Taiwan recently said we have resonance. They replicated the effect. But that was basically one component of the system required to make it work, not more energy out than what they put in. But they did make that milestone. A guy named Emmett Butler, who he said, I know how this works, I've got one running, and I'm going to tell you how I'm doing it. And he was sending me about one email every 4 or 5 days, and then he stopped. I don't know what happened to him. If the powers that be came and did a thumb screw on him, I don't know what happened, but last January we just stopped hearing from him. So I don't know what happened to him. Emmett, if you're out there, hey, keep him coming. Next. Number 3. Andrea Rossi is a cold fusion technology, and this is a technology which is getting very exciting. He's been at it for 3 years now, publicly letting people know that he's got this technology. It's using hydrogen to produce copious amounts of heat through a cold fusion process. The hydrogen probably goes to like helium, and there's also nickel involved, nickel going to copper, and liberating huge amounts of heat in the process. And that one, I went and saw that in operation in October 28, 2011 in Bologna, Italy. I got to see a 1 megawatt system. 1 megawatt, by the way, is like a small locomotive engine pulling a train down the tracks. So he had a 1 megawatt in a 20-foot shipping container with 106 of these 10 kilowatt systems inside of it, modular. And he had it running at half power, self-looped for 5 hours while there were about 31 of us witnessing this thing. Not that we weren't able to be in the room with him. He had there was a group that was going to buy the technology, that bought the technology, who was there the full time. Okay. And they bought onto the technology. Now they have been, the company has been bought by Industrial Heat LLC. And they're like a $2 billion fund. So these guys are getting serious. That one doesn't work either. Is there an open source variation of that? Yes, there is. And this one is actually something I've been experimenting with. Here you take what's called Brown's gas, which is electrolysis of water. You take a positive and a negative electrode. You've got water, and it turns into gas. And usually you separate the gases, hydrogen, oxygen. But in this case, they're actually taking the gases together, which is called Brown's gas. What if you take that Brown's gas and you put it across a catalytic converter on your car? This little matrix it has nanoplatinum, nanopalladium. These are the elements that you see in cold fusion research. You have a platinum electrode, a palladium electrode, and that's what you have on the nanoscale in a catalytic converter, the ones that you have in your car right now. So if you take Brown's gas across a catalytic converter, you've got the hydrogen, high-power hydrogen in the form of the Brown's gas, interacting with the platinum, palladium, or whatever, and you get a lot of heat on the output side. So I said, well, let's design a product and let's open source this. This is easy enough. Everyone can make the Brown's gas machines or buy one and get a catalytic converter and start heating your home with them. So we got the components. You got the catalytic converter in the upper left-hand side. We talked to a manufacturer who's able to plug in different elements in any ratio that we want, pretty much. There are some limitations. And they send us one without the insulation because you don't want to insulate this. You want it to radiate the heat. We got a Brown's gas generator from Orem, Utah, just up the road from me in Utah. And we put it together. And May 1st, we did our second test. We had a water bath with insulation around it. It had the electrolysis unit, a power supply from just a regular battery charger. With a rheostat, you could turn it up and down, AC rheostat, and we were able to control the power. We were getting about 1.5 liters a minute, and we put it into the HCAT, set it, and had waterproof, airtight caps on both ends, set it down in the water, and let it run, and let it heat up the water. So we were measuring how much energy was going into the Brown's gas generator, and how much heat was going into the water, and that's the power supply that we were using. We ended up using a battery charger because this one was defective from Hong Kong, so that one was out. There's our data. You see the nice little curve as the water's heated up there. There was room temperature there to begin with, and then it heated up, and then that was the cool down when we turned it off. And from that, we were able to calculate. Go ahead. There's the input power from the mains going to the battery charger. The battery charger is not that efficient. And then the input power from the HHO generator, the DC going into the HHO generator, that was our input that we calculated. Okay? And we also extrapolated, actually, after we turned the electricity off, the heat inside the catalytic converter was still hotter than the water and continued to heat up the water. And so you'll see there that the water temperature kept rising so that the cool down actually went higher, points to a place higher than the last temperature reading that we took when we turned the power off. So we took the full difference in water temperature from the hottest to the coolest. That's the output. And we got 104% efficient. Taking into consideration that the measurements themselves, just the input of electricity and the versus the heating of the water was 89%. And then you have the heat losses. You have the heat loss to the environment, you have the metal tub, you have the weight at the bottom of the holding the thing into the water. And so when you calculate those in, that's about another 15%, which gives you 104. Now here's the kick. Modern physics would predict that the best you could do in that situation, if you had the most efficient electrolysis and the most efficient catalysis process of taking the Brown's gas back to water, be 85%. And multiply those together, that's 64%. That's the best you could do. We're way over that. Now, it's not super exciting, but remember, we're at room temperature. So that's not bad. I think there's something going on here, and this is open source. I just told you how you can make one of these things, and you could start, manufacturing these, build a heater, make a water heater, make a home heater. I just told you everything you need to know right there. So that's open source. And it's probably cold fusion because you have the hydrogen and you have the platinum, palladium. Last month we did another test, our first test, and that was 70%. And that's barely over 64%. So it's like, well, I was confident enough, so we did the second test. We cleaned some things up, and that was colder than room temperature. This was outside a month ago, so we were wintertime in Utah, and it was in a kind of a outside, not solarium, but an area next to the house, and it was a cloudy day, so any solar gain was not that great. So the room temperature was like 65 degrees Fahrenheit. What was it in Celsius? Like 18, 17 degrees Celsius. Go ahead. The input here, this is the test we did on last week. The input was 1.5 liters a minute of gas going into the catalyzer. So the gas is going in at that rate. The output coming out the back end after the gases have passed across the catalytic converter, 0. You would hold this thing in your hand like this. It would just barely be warm, and we'd have the output hose going down into the water, blub, 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 bubbles would be coming out, blub, 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 blub. And then it would stop, and the thing would start getting really hot really fast. And it would actually start sucking water up into the hose. It's still going 1.5 liter a minute on the input, and it's sucking water on this side. So 0 gas actually is negative, if anything, on the output while you're putting all this gas in. That's pretty interesting. So there's at least 2 phenomena going on, because when you're holding it in your hands and you've got gas coming in and it's slowly heating up, that's one principle. So it's catalyst of the HHO gas back to water, producing heat. That's classical physics. No one's going to argue with that. But then it starts getting hot really fast. The second thing's kicking in once it gets up to a critical temperature, and then we put it down in the water. And so that was a difference. We didn't do that last month. This time we did. So we got over 100% this time. But that was still at low temperature, room temperature, and the water bath was keeping it fairly cool. What if you were to let it be in the room temperature, put some fins on it so you can blow air across it and heat up the room with it? That's coming next. Okay? Somehow the font size on this computer is different than on my computer, so I apologize, things are not wrapping the same way as they were on my computer. Go ahead. The open source project is available at hcat.me. Okay. What about number 4? Blacklight power. This is a process that has been peer-reviewed and has been published in peer-reviewed journals. And it is basically involves what's called a hydrino, which is like a low state of hydrogen going to normal hydrogen going to a lower state of hydrogen, liberating heat in the process. And these guys are close to having a system running where you could produce a 1 foot cubed system could provide 1 megawatt, 10 megawatts. Crazy. 1 cubic foot, the reactor size. And these guys have a lot of funding, and I would guess that within 6 months they'll have a process down where they'll have continuous output. Last month they published that they were able to get continuous output for like 30 seconds, a minute, but we need to have something that will, go continuously for years. They're not there yet. And that one doesn't have an open source equivalent. That was too expensive, too complicated. So no, there aren't any open source ones on that one. This is actually another Qmogen, which is number 2 in our top 5. So there are open source variations of this one. This is a company in Ukraine. All is not chaos in Ukraine. This company their business is headquartered in the UK, but they're actually physically located in the Ukraine. They're looking for money to go into manufacturing, building 0.5 megawatt to many megawatt size systems. So they're not wanting to start out powering people's homes. They're wanting to basically provide alternatives to coal and natural gas, so that power suppliers have a clean source of power. That's what they're going after. And so they're basically ready to go into manufacturing. This same company has also produced a software program that they say is 10 to the 20th times superior to the A1 level of U.S. national security software. Now, for me personally, I don't see the U.S. government as being the good example of security and software, because they're the whole reasons that we're vulnerable, is because the backdoors that they required us to build into the software also give backdoors to hackers and viruses and all that kind of stuff. So anyway, they're developing software, and they've got that for sale. When we're talking about top 5, obviously we don't know everything. There could be sleepers out there, the ones that we haven't heard of before. There are things that we know about that we can't talk about yet. There are, things are moving dynamically. So as you go to our listing, be apprised that that's not necessarily the very best things in the world. That's our list that we can provide right now. Okay. Back again to talking about open source and the ideal attributes. The projects that I just told you have strengths and weaknesses on these attributes. The one I'm about to show you hits every one of these at about the highest level that you can get, except the first. It's still working on the first one in terms of just how good it is, but I want to make a case that it's definitely good enough to be interesting. We don't know just how good it is, but we know it's very, very good. Okay. Here it is. Mike Waters is my friend. He's the president of the New Energy Systems Trust that I founded 2 years ago. He was with us at the founding. And he came up with this technology years ago. It's just been in his hip pocket, just something that he thought of, that just one of those things, what if, and he gave a presentation last October in Boulder, talked about this, Somebody in the audience was like taking notes, and they went and built one and tested it, and the numbers are so phenomenal that he's embarrassed to have me even say it without having like major third-party verification of this. But let's just talk about it for a second. What is this? In a normal windmill, have you ever thought about this? You've got these 3 blades, and you've got all this wind coming in, and where's the greatest torque? It's right out there. And where's the thinnest part of the blade? Right out there. And where's the thickest part of the blade? And where's the least torque? I mean, if you're going to open the door, if you push on the wrong side of the door, it's like, there we go, right? The same thing with a windmill. The greatest torque is way out there. And his blade, the incoming air goes out to the outside and spins the thing. Is that me? Is it working now? Okay. All right. So his device pushes all the air out to where you want it, which is where the leverage point is, where the leverage is the greatest. And you have this principle, force equals mass times velocity squared. If you double your speed, you go 4 times on the power. And so out here, you've got the incoming air. It actually accelerates as it goes out toward the side. And so you've got this faster air hitting it where it has the most torque, causing it to spin. Okay. What about surface area? You've got, these 3 blades, and all this incoming air, and most of it is just going right through without doing anything, right? You've got this surface area, so to speak, that you're hitting, and you're only getting about 5% of it. Whereas on his, 100%, all of that incoming air is being used to turn the thing at its most leveraged point. Okay? And also, if you think about it, on the torque, where most of the torque is, there's also this factor that you have, not sure what I was getting at on this one. There's a lot of deep thoughts on this. I was just pulling this one together today. I apologize. I can't remember the point I was trying to make on that one. Here is a little statement he gave me this morning. I won't try and read through that, but it's his dry British humor where he's talking about using drag to reduce drag and why this is a good idea and how drag becomes your friend in this scenario, whereas with the airplane wing equivalent wind turbines we have now do everything they can to reduce drag, but you want to capture the wind. You want to stop it. Because that's where you get the energy. You stop it and you make it do something else. Turn this turbine. From a bird's point of view, what turbine? Quack, whack. That's what happens to the bird. Do you think a bird's going to see that second turbine? You're not going to have birds flying through that thing because they can see it, they'll go around it. Whereas with the wind turbines now, they kill birds all the time because they don't expect how fast these blades are coming around. They don't see it, and then it kills them. Also, you've got incoming storms. So you have a big wind. They try and stop those things, whereas all you have to do is just turn it sideways like the farmers used to do and still do, the old farmers. They just turn it so it's 90 degrees from the wind. That tail fin basically keeps it out of orientation of the incoming wind. No big deal. What's the relative size that we're talking about that would produce the same amount of power as that big, huge 1 kilowatt or 1 megawatt system? That just gives you a ballpark idea of how big we're talking about. What kind of efficiencies are we talking about here? Is it 50% better? 2 times better, 5% better. This is where we don't have the answers yet, but I'll just give you, I'll let you know that somebody has done the testing and they gave that last number 50 times. This thing is 50 times more efficient than the 3-bladed wind turbines that we're using right now in the world. 50 times. Now, sorry, Mike, I know that's not third-party validated. You prefer to stay with something more conservative, 10% or 10 times. Okay, so 10 times, we'll say 10 times. But it's phenomenal. The only disadvantage of this thing is because there's a lot more material involved. In terms of if you were to build the exact same size, that would be a lot of mass. But because it's more efficient, you don't need to have as much mass. So you can see the size difference. That thing on the right is going to have less mass than the thing on the left and do a lot more work. And this is open source. This is I just told you everything you need to know about this. It's, basically it's, you have these things, the HEPA cages, or they actually use them for I think it's called a HEPA fan. And it's the same design, except it's used for blowing air, and it's very inefficient doing that because you're not doing it the right way. If you have the wind going into it to harness it, it works great. And so there's all kinds of things you could do with this. I grabbed the domain name waterseffect.com, which forwards to a page right now that he's got. This is so new that we talked about it in our Nest meeting last Thursday, 3 days ago? 2 days ago. Today's Saturday? Yeah. 2 days ago, we talked about this project and taking this on as our #1 project as the New Energy Systems Trust. He happens to be the president, but he's also the inventor of this idea, and we think it's great. It's a great bridge technology because it's way outside the box from conventional energy technology, and it helps people realize there's more where this came from, and that conventional science doesn't know it all. And you could sell these little kits. You could 3D print this thing so easy and make a little toy for a kid and show how well this thing works. You can turn it 45 degrees. The wind's coming this way. Turn it 45 degrees, and it works almost as good as if it's head on. So you have a 90-degree angle or difference where the wind can come and make this thing turn very well, almost at 100% efficiency of what it's capable of. All kinds of advantage. You could retrofit existing turbines. You could build new turbines, do things that turbines could never do before. This thing will start turning at 2-mile-an-hour wind. That's like, you could barely feel that 2 miles an hour, and that thing will start spinning. It takes 7 miles an hour for these 3-bladed spins just to start turning. And this one will start turning at 2 miles an hour. So again, this cognitive dissonance thing of, well, if something like this were possible, why didn't they invent it before? Surely somebody would have thought about this. And so you just bury your head in the sand and you walk away and you think it couldn't be because the smart people I know in my life would have thought of this by now. And so it couldn't be possible. But we know that there are many examples in life where things that are facts, that if you just look at them and think about them, are obvious. So there are solutions galore. And again, I apologize for the pagination, the different font size, but solutions galore. There are many answers out there to the questions that we have. How about here in Brazil? These guys are in our top 5. They're actually, they kind of in and out because they're taking longer than what we expected. They're up north. And Fernando Lins is here. He's in the audience. Where are you, Fernando? Right there. Yeah. He's been involved in helping us translate and communicate with these guys and working with the guys who want to fund this thing to do the mass production, to bring it to market. They're talking anywhere from a few watts to many hundreds of kilowatts capable. That thing right there, I think, was a 10-kilowatt system. It's just a little about this big. Solid state, no moving parts. That's very exciting stuff. And once that thing's fully validated and in production, it'll probably bump right to the top of our top 5. So that one's very exciting. Har Energia is right here in Porto Alegre. That's a humongous gravity machine. And we were hoping last year to go visit them and this year to go visit them, but they say not yet, not yet. They're waiting to do a big, huge launch in July. And so basically you have something that physicists say is impossible, where you harnessing just static gravity power and turning it into rotational torque. I mean, they obviously believe in what they're doing. There's a lot of money and a lot of equipment invested in that thing. Kepi Motor up in Sao Paulo. These are good friends of mine. I'm going to be visiting there hopefully after this trip on my way back. And they have a fan which uses the principle of resonance with the environment, and they actually have been validated to provide they're like the most efficient fan in Brazil. They have received their UL certification, so they're ready. They've got a manufacturer in China, and their efficiency is probably so high because it's getting help from the environment. And once they tweak that, they may be able to get to the point where they've got a generator, not just a motor. But right now they've got a motor that's the most efficient motor in the world, probably. And so that's just north of here. We're going to talk about other runners-up, but we want to open it up to questions, so I'm just going to flip through these really quick. Another Qmogen, another cold fusion technology, water heater technology, Qmogen, solid state. You could have a phone, an iPhone, that never has to be charged with the power supply that would be the size of a postage stamp with this technology. Another cold fusion technology. The size of a pencil eraser, amount of fuel is how much it replaces 2 50-gallon drums of fuel. That's how much power density they have. Another cold fusion technology, actually cavitation, which is a sister of cold fusion. Massive yet tiny engine, a lot of exciting stuff going on there. We provide jetpacks so you can fly 100 miles on something you could carry 45-pound pack. You can have craft that go across the water using the ground effect, so you can get across the oceans with a cargo ship, basically a flying cargo ship, in a few hours rather than a month. It's just a few of the sampling that we did, and you can subscribe to our news, freeenergynews.com. We have a link in the upper right-hand corner for a free subscription by email. And then we just recommend this book, Breakthrough Power, by my friends Joel Garvin and Gene Manning. Give you a primer of what's out there and available. And thank you. Any questions before we end? Obrigado, by the way.
Hello.
Yeah.
Hi. This looks like lots of promising future and looks like sci-fi movies. Do you suffer or you're afraid of some like conspiracy theories from like oil companies and stuff who would be scared about all these new technologies?
I got most of that. You want to say that one more time?
Because we were thinking about the conspiracy theories about with oil companies who were against the electric car and stuff like that. So, is there any lobbies from the oil companies and is this real conspiracy theories? Are you afraid of something like that?
I missed one of the key words. Were you talking about lobbies?
Yeah, lobbies from oil companies.
Oh.
Because that would be totally against
Yeah,
their
are they trying to
profit.
shut this down?
Yeah, I mean,
Yeah.
it looks like sci-fi movies.
So the question is, there are people out there, including the solar industry, who have a vested interest in solar, and this stuff makes their stuff obsolete. I don't need solar if I can, you know, if I've got a device that pulls energy all 24/7, the sun doesn't have to be overhead. Even these technologies make wind obsolete. And so, are there forces out there trying to suppress this? Yes. But since when has that stopped human beings? I mean, you all in this room know what it's like to go up against a vested interest, and you just do what's right, and eventually the new technology makes it. So, yes, there are opposing forces, and yes, sometimes they get very ugly, and they kill people, and they torture. Yes, all of that stuff happens, but we as human beings rise above that, right? Yeah.
How about the relation between the free software philosophy and this kind of new energy systems being developed and applied?
Okay, again, the relation between...
There is relations about the philosophy of free software and the free energy.
Okay, what's the relationship between free software and free energy? Free software basically gave birth to the whole idea of open source. You understand what open source means, how it works, how it's implemented. We are now ready with several technologies to open source them, to bring them to the planet. We need your help to figure out the mechanisms, the logistics of getting these things implemented, creating the forums, creating the feedback, creating the websites where somebody who's selling this component, they can get it listed. That's all software. And so we need friends in the software industry to help us launch this stuff into the planet. Thank you. Open. Okay. Okay. Okay.
Oi. Aqui.
Okay.
Você falou ali sobre um conceito de ressonância entre dois motores que geraria um output maior do que o quanto de energia você colocou no sistema. E realmente esse é um conceito que eu nunca tinha ouvido falar. Você teria como elaborar mais no lado científico desse conceito de ressonância? O que seria isso? Porque para mim não ficou muito claro. Assim, você só citou e é uma coisa que eu nunca tinha visto. Eu acho que se você pudesse comentar desse conceito, se fosse possível.
Okay. Sometimes okay, I'm going to take this off. So, sometimes we have to take things on faith because we don't understand. And this is one of those things where I don't know anyone yet who has a really good model of what's going on and why this works. The best way that I could describe it would be resonance, where if you put your foot on the loud pedal on the piano that sustains the notes, and then you sing a note, that note on the piano, that will start vibrating. And there's something to do with resonance that as these things start getting into a certain harmonic, it gets a vibration going with the environment that locks in and brings in that energy. That's the best way I can describe it. And that may be inadequate, but it has to do with, it is coming from somewhere. We don't know how and how to control that yet. So you software engineers have scientific minds. That's another thing you can do to help, is come up with models and tests and jigs and to figure out the science behind what's going on. would actually be a very good computer engineer question. We're out of time, aren't we? We have time for one more? Okay.
I don't know if I'm being too much invasive in the questions, but anyway, we know about the captor device, and we have here Fernando Lins that was there doing measurements. And my question is about how much time we will need to see this being selling in our market in Brazil.
He's asking how long before we'll see these things sold in the marketplace.
Yeah.
And to ask me the question is the wrong person to ask that question, because I've been chasing this for 12 years, and for 12 years we've been 3 to 5 months from market. Okay? And we're still 3 to 5 months from market. But now, you saw the top 5, and they're all in the process of needing money for mass production. So that's a good sign. And also, if we open source, that makes it available right now. So really, that thing I showed you with the wind turbine, you could go home today, 3D print one of those, put it on your bicycle wheel, hook it to a generator, and power your house, no? So we're really already there, but it's just a matter of when you say mass production, being able to buy one, then you have to get certifications, you have to get verifications, you have to get the funding, you have to get the business plan. There's all these steps that are required, and it's not an easy process. But you could argue that right now we already have things that are available through open source, but in terms of commercial, 3 to 5 months. Did you have a question, Fernando? Okay. All right, thank you. Obrigado.